Hey guys, today we're going to be looking at some more ways of organizing univariate data, particularly the box and whisker plot. So the box and whisker plot is also called the box plot, and I think you guys saw this last year. It's a way of organizing data so that you could see the spread of the data, how spread out it is, and you can only see certain highlights of the data, but you can't see all of it. So here are two examples of box and whisker plots. I'm going to look at the first example and just kind of label the key features. The box in the middle here, this line represents the median of your data set. So this is telling me that the median was 12. Okay, median equals 12. And it breaks up your data into 4 sections. Each section represents 25% of the data. So 25% of your numbers are in this lower section, 25% are in this next part of the box here. So you've got 25% here of the data, 25% of the data are represented in that part of the box, and then 25% of the data is in this part of the box. And then you have 25% of the data in the top section here. 25% is here. And so it divides your data into fourths, right? And each part that divides like one section from the next is identified. So the median divides the lower half from the upper half. Your median is 12. The number that you see in the beginning of the box that I'm highlighting in black right now, that, which is looks like it's 8.5, is called the first quartile. First quartile is 8.5. So 8.5 is the value that divides the lower half, or the lower 25% from the next 25%. And then on the other side of the box, which I'll highlight in, I'll do that in green, over here on the right side of the box, at 14, 14 is called the third quartile. And so that 14, that 14 value divides the upper 25% from the 25% below it. So when you look at this, you could tell what the lowest value is. That's all the way at the bottom dot. The lowest value is over here, which is 5. That's called my minimum. And you can tell what your highest value is up here at 20. That's called your maximum. So you can only tell like certain highlights of the data. I could tell my lowest value is 5. My highest value is 20. I could tell you that the median, the middle, is 12. The median is also known as the second quartile. So you have a first quartile at 8.5 here. You have a second quartile, the median, at 12. You have the third quartile at 14. And that tells you the division of each 25% section. Now, why does one 25% piece look bigger than another 25% piece? Because the data is more spread out. So when the 25% section is wider, the data is more spread out. So that means that like you have, if you had like say 20 people in a class and you divided them into fourths, you'd have 5 people in each section. So this would represent 5 people, and this would represent 5 people, and this would represent 5 people's scores, and this would represent 5 people's scores. But these 5 people have their scores more spread out, maybe like a 15, a 16, a 17, an 18, a 19, and a 20, whereas the blue section, those 5 people have their scores, they're all very similar and close together, like 12, 13, 14. That's it. So that's what we mean by more spread out. So the smaller section that looks smaller, that 25% section, is less spread out. And that's what a box and whisker plot lets you see. It lets you see the spread of the data. There are some other names. The first quartile is also known as the lower quartile. And the third quartile is also known as the upper quartile, which makes sense. That's not hard to remember. So if you look down below, you have Class A and Class B. Class B, even if they have the same number of people, Class B has their data more spread out overall. And also their top 25% up here is much more spread out than their lower 25%. So let's say their class had 20 people. Then there would be 5 people here, 5 people here, 5 people here, 5 people here. But these 5 people at the bottom, their scores were all very similar and close together, just between 72 and 73. Whereas these 5 people up here had their scores more spread out, 87, 88, 89, 90, 91, 92, 93. Okay. So you could tell from Class B that the median is 80. The first quartile or the lower quartile is 73. The third quartile is 87. My maximum, my highest score was 93, and my lowest score was 72. So you've got the box represents altogether the middle 50% of your scores, of your data. Okay? You cannot determine from a box and whisker plot, you cannot determine the mode. You can't see frequency here. You can't see how many times a score appeared. You cannot determine the mean because you can't see individual scores. All you could tell is the median and the quartiles. Okay. Also, we have a concept called interquartile range, which is, you know what? I put it here. I should have put it up. So it's down here, but I'm going to write it over here. The concept of interquartile range. So you guys have learned in the past that range is the highest minus the lowest score. If you want to know how spread out data is, you take the highest score and you subtract the lowest score, and that's called the range. Well, the interquartile range takes the third quartile and the first quartile and subtracts them. So in the Class B, I would take 87 minus 73. And that's a more stable way, It's a more stable way of measuring the spread of the data because you're taking the middle 50% and you're finding the range of the middle 50% as opposed to taking the highest and the lowest, because if you take the highest and the lowest, then you might have some outliers. You might have like one kid who got a 40 or only one student who got 100 and everybody else did not. And so the range is not preferred. Instead, we prefer to use what's called the interquartile range. So it's quartile 3 minus quartile 1, which in this example of Class B would be like 87 minus 73. So you would say my interquartile range is 14. Okay. We're now going to look at making box plots. So I'm going to switch over to a different video so this doesn't get too long.